Hi everyone, Magnus Thor from Team WebSockets here. I'm about to build a simple product finder using WebSockets.net. I prepared a demonstration by building this sample web page. We will be able to enter a text in this text box and get results from the database underneath search results. I prepared the demonstration by creating a web page. You just saw it's a simple web page that includes jQuery and the JavaScript API that belongs to WebSockets. I also added the necessary stuff to the project by just typing install package WebSockets. When you do this, you will receive a folder in your MVC3 project named WebSockets, which contains a folder called development server, which is the development server that you can use for development purpose, etc. It also adds the necessary files to build the client using JavaScript. This is the JS API of WebSockets, etc. We also need jQuery to do some DOM manipulation. The WebSockets NuGet package also adds a project named WebSocket Handler, in which you can put your custom WebSocket handlers that contains your specific logic. A WebSocket handler can be sort of compared to a controller in MVC. I also build those two models, a model that will be corresponding to our query and the name is being called look for, and we also have a model for or class for the product. This is the actual result we will be sending back to the client when time comes. We can add WebSocket handlers by using the scaffolders. WebSockets, I type scaffold and we just type WebSocket handler and give it a name. We will call our handler product finder. When you do this, you will receive a class in your project named product finder. We can open this up and see that we have a metadata attribute which corresponds to the class name product finder. This is the alias of our WebSocket handler or controller. In this case, we need to have a database, as we mentioned, query, private, data access, model, entities. I'm using the AdventureWorks database. We also need a constructor for this class, this handler, in which we will be creating the new context and instance of our model. Like this. We also need a couple of new things. We need to have link to query our model. We also need the WebSockets core, the WebSockets helpers that will be helping us to send back the information to the client in a very convenient way. When this is done, we need to create a method or event listener on the server within the handler that will be receiving our inbound messages that we'll be sending further on from our JavaScript client or web page. This will be a public void, and we'll be naming this product finder. Find product, and we're passing the query into the method, and we also need to give this method a attribute called handler event. This enables the WebSocket server to route messages to this event, and the alias of this event can be find example. And now it's time for us to query the database for some results, and we'll be using the context. And the product entities, and we'll be filtering those products upon name. The name should also contain the value that we pass in. We look for property, and we can make this to lower. And we need to send back some information, and passing back a new instance of model product, as I showed you earlier, and we'll be setting two of those properties of the model to product ID equals speed of product ID, hopefully, yes, and we will also be able to send the name of the product equals name. As I show you, we are using the helpers of XSockets. You can use this as this is socket to use async send. There's a lot of helper methods available in XSockets. We can do async send. Async send will send back the message to the client that sends it to the handler. Async send to, then we can specify which instance of this handler we can want to send to. For instance, there are 4 users connected to the WebSocket handler named product finder. We can target different of those, or just send to everybody listening to the product finder. In our case, we will send back the query to the user or client sending the inbound message. We will pass back the results, and we'll be giving the message event name. This is the name which we will be subscribing to on the client side, and let's call it on result. Very easy. Sorry, result. This way. This is the things we need in our WebSocket handler. I'm going to compile this. When I compile, there's a post-build command on the project that will be moving the assembly to the development server folder and the XSocket server plugins. So see here we have a copy of the assembly of our handler, and we also have the data access DLL, the entities that we are using. We can now start the server by opening the container folder and just start the development server like this, and type handlers, and we will be giving a list of available handlers in the server. We have the product controller, which is another example I made, and we also have the find products handler created, product finder created just recently, and also the generic text and generic binary handlers, which is built into the server. Okay, so now let's have a look at the client side. As you see, I included the XSockets into the page, as well as the query. Created a variable called WS, which will be our socket. First of all, we need to create an instance of the AS API, the socket, the XSockets, sorry, and we will use the WebSocket class, and we will pass in the server URL to our WebSocket handler. This is the server name, the port, and the handler. This will be a product finder. This is the name of the product finder of the handler you want to connect to. When this is done, we can bind listeners to events. One event is open, it's a native event, of the WebSocket protocol. When this is done, we will have the possibility to bind some more events. In this case, I want to bind the onResults event. In this case, we will be receiving a list of products like this. And now we are listening to the onOpen event. When this is done, we fire up yet another event listener or subscriber for onResults. onResults corresponds to the name of the event you are sending to the server. When this is done, of course, we can start by clearing the result list vars, which is an URL, because we're going to receive data quite rapidly. We empty those, and then we need to iterate through the list of products that the handler will be returning, and we'll be using products. And when we do this, we want to create a new element, which we are an RE element, and set the text to list.product name. But this is one property of our product model, as I showed you earlier in the server-side code. Let us now add this object to the results element. When this is done, we are now subscribing to the open event and are subscribing to the onResults event triggered by our server. We also need to subscribe to changes on our input element here. When people type something in this box, we need to pass a message to the server to our WebSocket handler. As you may remember, we have a handler event called find. This is what we will be triggering from the client of ours. So first of all, we need to create an event handler for query, which is our text box. It will bind the key up event, and when this event occurs, we must send a message or publish a message to our WebSocket handler. This is done by the trigger method, and as you see here, we have a string. This method expects a string event. This will be find, corresponds to the handler event attribute of our method, and we will be passing a JSON object here, which I will be constructing now. JSON here, in fact, the query. Make it more clear, we will use query instead of JSON. Query, as you may remember, has a look for property. We can look at this later, and we'll be using the value of the query form element. This is what we do. We construct a JSON object called query, set the property look for to the value of the text box, and we trigger the find event on the WebSocket handler, which we are connected to the product finder. When we receive a message, we will be clearing the list of products, and we add those that we got from the WebSocket handler. Server is running, as I showed you earlier. So now let's restart this page and do a test. Start bike, nothing happens. That's wondering why. Let us see if there is something yes, there's data sent in and out to the server, so probably there is just something wrong with the listeners. So yeah, as you see, I'm sending back the message, the result, to the event or listener named on result, and I type on results in my JavaScript. So instead of shutting down or recompile the handler, I just be changing this to a result and try to do a reload. Let us also take up the debugger and see how it looks like now. So let us write here bike, and you will see that we receive some data. I will getting loads of data from the server quite rapidly. So let us do a review test here, like helmet, sport, quite fast. This is how we can build things upon the XSockets.net framework. We can also have a look at how we add fallback for browsers that doesn't support native WebSockets. As this is Chrome, we have native WebSockets available, as you see here, using the RFC protocol. And if we do use Opera, for example, we will also be able to run the example because Opera supports it as well. Right? You can also add and try to run it inside Firefox like this, and do the same for sport. Yeah. Let us shut those down, or perhaps go to Windows and add a couple of more JavaScript resources to the web page. We need to add a JavaScript file, named XSockets WebSocket detector to our page. We also need to add the SFD object-based file because we rely on Flash if we don't have native WebSockets. That's what we need to have within our web page, as well as we also need JSON2 reference. If I now open up the Internet Explorer browser and copy the URL, let us see if we got the possibility to run the same solution relying on fallbacks. I will type the same thing here, men, and you will see we have the same results on the different browsers. In this case, Explorer, it will be relying on Flash. We can also open up Safari, etc. To see that we have cross-browser support. One more thing that we can have a look at is if we shut down the server here, all clients will be disconnecting automatically, but we can just change in our product finder handler. Instead of sending back only to the sender, we can do async send all. Sorry, just do async send to all. This will broadcast the message to everyone listening to the current WebSocket handler, in this case the product finder. We compile, and I will be opening the development server once again. If you run the outside development server, you're able to just add those plugins to the server without restarting. So now let's have a look. The service we started. We can open up page once again. We will refresh on the Chrome browser. I will do a refresh on the Opera browser, and we will refresh on the browser Aurora, Firefox 11, and also try to do the same here in Explorer. You may notice I did use the async send to all. In this case, I will type in Explorer like the bike, and you will see like the same message, the same query, or the same results were pushed to every other client. We do the same here in Chrome or in Opera, like a rack. Yeah. So this is how you build custom WebSocket handlers upon the WebSocket framework. I think this is quite a convenient way of solving problems like this. Have a nice evening, and thank you very much, and thanks for listening to yet another WebSockets Unplugged demonstration.